So with our second e-learning day of the week, we are going to take what we did yesterday and do vertical and horizontal shifts on the trig functions. This isn't as difficult as it sounds, and this actually covers just 8 problems that your homework asks you to do. So let's kind of get ready for these. First, my function form, y is equal to a sine of x, is going to be modified. So I kind of described, actually, I was to a sine bx. I kind of described yesterday that a acts as a vertical stretch. It tells you how tall your frame box is. How tall your frame box is. So if I'm drawing a graph and I put a frame box in like this, the height of it is actually 2a. It tells you that you're going to go a up and a down. B, on the other hand, if a is a vertical stretch, b affects the horizontal stretch. I'm just going to put affects the horizontal stretch. And since the regular period of a sine graph is 2 pi over b, the 2 pi over b is the new period. We also were calculating or figuring out what happens if a is negative. So I'm going to throw that over here. If a is negative, the graph is inverted, and we're going to use a more mathematical term here. The graph reflects about the x-axis. So all of that came into play yesterday. Today we're going to do a few more tweaks to this. A sine of b times x minus h plus k. And what k is kind of the new location of the base point. Hk is the new base point. This lets me take the graph and shift it up, down, left, or right. So let me do an example of a simple one on how this is going to look. Y equals the sine of x plus 3. So first things first, we're going to put a grid down. I'm going to identify that my vertical stretch, or my a value, is equal to 1. My period is 2 pi over b, and since b is equal to 1, my period is 2 pi. And then I'm going to talk about something called a vertical shift. And the vertical shift is affected by this value here. That's going to be up 3. And then the horizontal shift is affected by a value that would be in here. So there is none. There's no horizontal shift. So vertical shift means that this point that was the origin is going to go up 3 units to that new point. Then I'm going to draw a frame box that is 1 up and 1 down, so up here and down here, and it goes right 2 pi units, which again we moved right 4 units and just kind of put 1 there. So I'm going to put a box in like this. I'm going to call this 2 pi, call this pi. This is 3, and since we're going 1 up and 1 down, this is 2 and this is 4. So that's our frame box. Now I look to see what kind of graph it is. It is a positive sine graph. And since it's a positive sine graph, it's going to start at the baseline. So our new baseline, sometimes I'll put a dotted line here since this is the new baseline. It goes, well, sine starts and ends at its baseline. Halfway between its baseline, its start and its end, you have another point in the middle at the baseline. Sine goes up first and then comes down. And if I draw this carefully with each curve coming as a separate lifting of the pencil, I get a good looking sine graph. Again, like before, your directions are going to ask you to graph 2 periods. We're going to overachieve and do 3. So if I go right one more time and put, well, I don't need to put a frame box in. We're just going to continue the pattern, up, middle, down, middle. And if I go left, down, middle, up, middle, and I draw 2 more cycles, I get what looks like a pretty complete sine curve that has been shifted up 3 units. So that's what an upshifting looks like. Let's do a left-right shift. So if I go y equals cosine of, and let's do something like 5 pi over 4 plus x. And we're going to denote a few things under this. We're going to talk about the vertical stretch. I'm going to talk about the period. Then I'm going to talk about the vertical shift. And then I'm going to talk about the horizontal shift. So vertical stretch, a is equal to 1. There is no vertical stretch happening. Period. I know that if I rewrite this as the cosine of x plus 5 pi over 4, which is how it really should be, the coefficient of x is 1. So my period is 2 pi over 1, which is just 2 pi. This is because the b value was 1. Again, we're comparing this to y is equal to a times the sine of b times x minus h plus k. So my vertical shift is what's going on after. It's this right here, plus 0. My vertical shift is 0, so there is none. And my horizontal shift is affected by the h value. So if I look and kind of pull out what hk is, h is the opposite of 5 pi over 4. It is negative 5 pi over 4, and then 0. So my vertical shift is affected by this. It is left 5 pi over 4 units. So now it's going to get a little bit tricky, but not impossible, to graph this. If it's 5 pi over 4 units left, that means that maybe I'm going to want to make my boxes be every pi over 4. So that left 5 pi over 4 moves me here. So this is negative pi over 4, negative 2 pi over 4, negative 3 pi over 4. We're going to go to negative 5 pi over 4. That way I've got an even increment and I know exactly where to put it. So the period now is 2 pi, and my vertical stretch is a equals 1. I'm going to actually do this as much to scale as I can. We're going to just put 1 here and negative 1 here, up and down. And then if my period is 2 pi, and I'm in units of fourths, my period is actually 8 pi over 4, which is the same as 2 pi. That means that I need to count right 8 boxes and end up here at the end of my period, because my scaling has been done differently. So this actually represents now 3 pi over 4. I've gone from negative 5 pi over 4 to 3 pi over 4, and this is one unit of this graph. Now we're going to have to get a little bit tricky because this is a cosine graph. Cosine starts at its maximum and it ends at its maximum. Halfway between its maximum points is a minimum point. Halfway between its max and its min is a baseline point on both ends. And if I draw this very carefully, I now get a very stretched out looking cosine graph. And I want to do one more point, so let's keep the pattern going the way we did before, or one more cycle. I'm just going to do one more because I'm going to be out of room on the left side. So I'm going to make this one go to the right. But there's 2 cycles of cosine. So don't cram these in the margin, and don't do them without graph paper. I tend to use the boxes to my advantage, so I have a better sense of what I'm doing. Okay, we're going to do one more. Let's do y is equal to the sine of x minus pi over 4 minus 2. So this is both a vertical and a horizontal shift. My vertical stretch is just 1. There is no vertical stretch beyond just up 1 and down 1. My horizontal, or my period, is 2 pi over 1, or 2 pi. My horizontal shift, I can see by my HK value here is pi over 4 negative 2. Again, if I model y is equal to sine of x minus h plus k, let's not put the a and b values in, but if I just kind of look at that, that tells me what my hk values are. So positive pi over 4, negative pi over 2, or negative 2. My horizontal shift then goes with a pi over 4, that is right pi over 4. And my vertical shift is down 2. So let's put the grid down. And I want right pi over 4, so let's go right here. This is going to be pi over 4. And down 2 puts me here. That's my new starting point. And I want to draw a frame box that is 2 pi wide. Well, that lets me put 4 boxes and just call that 2 pi wide, which means 2 pi more than pi over 4 would be 5 pi over 4. Or not 5 pi over 4. 2 pi more than pi over 4. I actually need to go double that if I'm truly doing this. So I can't go that wide. Let's add. Let's go pi over 4 plus 2 pi, which is 8 pi over 4. I need to go 9 pi over 4. So I actually need to go 8 to the right. 8, because if every box is a pi over 4, I need to make this further. So we need to go here all the way out so that my period reflects that. So this, if I extend this out just a little bit more, this is 9 pi over 4, and let's see, it is a positive sine graph, and it goes up 1 and down 1. So if I mark my y-axis, this is at negative 2, this is negative 1, and this is negative 3. It's a positive sine graph, so it starts and ends at the baseline. Halfway between the two baseline points is another baseline point. Halfway between those two you go up, and halfway between those two you go down. So we go up like this, and down, and back up. And then same for here. We're going to go left because that's where we have room. Down, up, and up and down. And that's it. Your homework is 9 through 16 on the same page you guys have been doing before.